right, so here's your points. Now we look at your parent function. All right, no, is it a function? Well, duh. This right here tells me it's a function. That's in function notation, so that's a function. So it passes the what? Passes the vertical line test, no x's repeat. Domain, what's your domain? Correct. Every single number works. There's not a number you cannot plug in for x to make that not work. Okay? All numbers will work up there. So you can put whatever you decide. If I want to do 2 to the square root of 13, guess what? It will spit out a number. Okay? Range. Where's your bottom of this graph? 0. Correct. But it is not including it. So how do we make it not included? Yesterday, we included it because we had an equal sign. It makes a bracket, okay? But a parentheses is what you want here, okay? Brackets are equal to. Parentheses are not. So in this case here, you want a parentheses. If you want to write that as an inequality, it is just y is greater than 0. F of 4. So we're looking for f of 4. You guys already, hopefully you already know it's what, 16? Negative 4. 1/16 is correct. 1/2. What's happening at 1/2 right here? What is 2 to the 1/2? Well, that is the square root of 2. We didn't do that one earlier. That is roughly 1.414 if you use your calculator. Okay. Just so you guys know, so negative exponents create fractions. Fractional exponents create roots. So if I have 1/3, then that would be the cube root of 3. Okay? So you'll learn that next semester. But we're doing a little bit here, so why not introduce it? Moving on. As I said here, this is your horizontal shift right 2, up 6. So let's write the equation. We have f of x is equal to 2 to the x power. So how would I include a shift right 2? How would I write that inside my equation over here? It would go with the x, that's correct. So it would be 2 to the x minus 2. If you want to put parentheses around it, it's fine. It's going to be up top. It's an exponent. And then I'm going plus 6 is right. You want to put a plus 6 right here. There is an equal sign between that. Sorry. Okay? This is what your new function would look like, your transform function would look like. As you can tell in this one right here, my x's are lying to me, so I'm going right 2, and I'm going up 6. So all it's counted. It's the same thing that we did yesterday in our transformations. All right. Now your new table values, our original table values were, let's see if I can remember them. I think we had 0, 1, 1, 2, 2, 4, 3, 8. Negative 1, 1/2, and 1/4. All right. So I'm adding, in this case, I'm moving it right 2. So I'm going to take all my x values, which is this ones right here, these, and I'm going to add 2 to them. So my new point should be 2, 3, 5. Oh, wait. I can't add. That's a 4. Negative 1 would be 0 at 2, 3, 4, 5. Then adding 2 would be 1 and 0. Is that right? There you go. And this side over here, on this side, I'm going to add what? I'm going to add 6. So that should give you, what, 7. That should give you 8. Should give you 9. Should give you 10. should give you 6.5 and 6.25. Okay? Now, this is done, and we're doing it in table value form. It is important to be able to do both this one, and we're going to show you, I'm going to show you here in a second how to do this on a graph. All right, horizontal shift left 7. What's that mean? Minus 7. So it would be 2, and then you would have x what? Plus 7, that's right. And shifting down 6 would be minus 6. So now we're going to use those same exact points, the 0, 1, 1, 2, 2, 4, 3, 8, negative 1/2, and negative 2, 1/4. You're going to add, or sorry, you're going to subtract 7 from each of these, right? And over here, you're going to subtract 6. So you should have what? Negative 7, negative 6, negative 5, negative 4, negative, no, the negative would be negative 8, and negative 9. And then over here, if I subtract 6 from that to get negative 5, negative 4, negative, I can't do my math right. Negative 2, is that what you got? Positive 2. Negative gives me negative 6. No, it's not negative. So it's 5.5. So what you guys got? And here you got 5.75, right? But they're negative. These are. All I'm doing is adding or subtracting. Okay? There isn't really any magic. Okay? We do need to be able to write it into transformation form. So my parent function, in this case, my parent function is f of x equals 2 to the x power. As I said, we will be transforming lots of different parent functions, and this one happens to be the exponential growth. We do have an exponential decay that we'll be talking about in February, in March, so we'll be dealing with that. All right, now, in this case, I want to show you what to do if I know it's being shifted. So, in example number 2, let's just say I had to graph this one, and you said the new transform was f of x equals 2 to the x. What do we say? What's this equation? Right, 2, which is minus 2, right? And plus 6. So, if I had to graph this, this is how I do this. I write my transformations down. I write right 2 up 6. Now, I don't do the table. You can do the table if you want to. But all I'm going to do here is I'm going to create a new coordinate plane. There's 0, 0 right there, right? So I'm going to go right 2, draw me a dotted line. I'm going to go up 6, I'm going to draw me a dotted line. What have I done with the origin? Shifted it right 2, up 6. So now, these are my parent function points. This is the image or the picture I want to transform. So I don't have to think about some chart or anything. I have already added and subtracted with the things I need to do. So I would take this, which is 0, 1, and on my new grid, the new one would be 0, 1 right here. Right? I'll do it purple so it stands a little bit different. So 0, 1. This one right here is 1, 2. So I'm going to go over 1, 2. It would be that point. That point right there is negative 1, 1/2. So I'm going to go negative 1, 1/2. So this is what would transform. So I have moved the blue graph right 2 and up 6. Okay? Now, you have to remember that I asked for transform points that you're not saying, like this point right here, this is what I have a lot of students go, that point right there is 1, 2. It is not 1, 2. It is 1, 2 on the original, on the new graph, but on the original one, that really is 3, 8. And if you look down here where you had your work, and you were looking at 3, you had 8 over here. So that matches up perfectly if you did the table. Okay? We're going to do a lot of our work on our grid. Okay? What we have to do, the first thing you do in order to get the order of operations, and we'll talk about order, you have to, in what we do in this class here is we move the origin, and then we draw a parent function, and then we squish it, contain it, and do all sorts of stuff. I'll show you both ways, but I primarily will do a lot of this work on the graph itself. Right? Enough on that. Let's take a look at your homework. Now, yesterday, we came up with this problem right here, number 3, in your homework on point 5. I'm going to redo it real quick here. I do want to show you something that you can do here. Yesterday, we put this into a slope-intercept form of 18. I asked you to graph that, correct? And Aubrey's like, well, where's 18 on the graph? And what do you need, Katie, what do you need to graph a line? A point and a slope. Okay, I have my slope. What's my point? Does it have to be 0 to 10? No. And that's the one thing I got pigeonholed in yesterday into just looking at the y-intercepts. There are different points you have. Guys, we know it's going to be up here, and it's going to come down this direction, correct? We know it's going to be somewhere over here. So all we really needed to do is pick a number over here. What numbers are good numbers to pick if I'm doing math over here? Give me something that might work of these numbers here. You say x is equal to, let's do 10. Let's just say 10. Why I pick 10 versus 9? Anybody? Why did not pick 9? It would give me a fraction. It's correct. If I put 9 right here, I get negative 27 divided by 2. I don't like that. But if I pick 10, I put 10 right there, I get negative 30 divided by 2, which is negative 15. So I get negative 15 plus 18 gives me what? 3. So 10, 3 is the point. And then I can use my slope. I can go up 3 over 2, up 3 over 2. And then have to struggle. Yesterday, if you watched the video, I struggled trying to get to that particular point. Okay? But you don't have to make it a struggle. You just pick a point. It's always good whenever you're looking at your slope-intercept form, if that was a 3 on the bottom, then I would pick like 9 or 6. I would pick numbers that I could divide easily. Does that make sense? So let that be a lesson to you there, all right? Just trying to help you out. Let's take a look at point 5. We'll put some of these, or point 6, I should say. So let's put some of these on the board. We're going to put the first 5 problems on the board. Let's see here. You guys can put number 1. You guys can do number 2. 1's there, 2's there, 3. Let's go with Gracie's sister. Okay. Yeah. Options in Kevin, you're going to be on 4. And let's wake up Madison. We're going to go with this. You're number 4. Board number 4 is right there. It goes 1, 2, 3, 4, right in order. Starting here's 1, 2, 3, 4. Yeah, nice. Lost and found. You lost your water bottle. What color was it?
Gray.
Gray? I'll check it. Give me just a second. There is a Maroon hoodie and a pair of sunglasses. No gray bottom.
All right, thank you.
Yeah. I think you could. Not horrible.
Okay, so it would be.
Yeah. You're smart too. You could have done it on your own. Yes. But you didn't really so you did something. You didn't. If you add them together, you got an extra one. So that means you need the same number but opposite signs. That needs to be up and down. That would yeah, pencil would work better. You can erase with a pencil. Unless you got a fusion pen. You have a fusion pen? Hey, you need a fusion pen so you can erase. Yeah, they're expensive. Get stuck out there, need some help? There we go. Andy, you alright? Yeah, you know the famous Annie Oakley? Yeah, she's a gunslinger. Yeah. I actually have a picture where I was sitting with her. So you go out west. There's a you go out west to Walls, South Dakota. There's like this super duper huge mall, kind of like a Gatlinburg, like all underneath one roof. Basically, it's kind of crazy. But there's Annie Oakley sitting in a chair. She's a bronze statue, so I sit next to her. I had a swimmer who used to go to South when South was a thing, and I went, and she was really, really good. But she was putting a play on at South, and I went to go watch her, and she sang the Annie Oakley. They did it Annie Oakley actually as a musical. So she was really good. Then she moved to Oklahoma, and she's went to college there and got married. But they're the Gattons, and I go see them frequently because as I go out west, their house is like the hotel. So they're in Oklahoma City, so I drive from here to Oklahoma City, spend the night, and you go to California.
Are we doing this today?
Do what?
Are we doing this?
Yes, you are.
Is Oklahoma cool? I've never been.
Oklahoma is cool.
What's up? Hey, Mr. Buck. Hey, it's Mr. Burleson.
Yeah, this is Mr. Burleson, if you have him as a counselor.
What grade level are we dealing with here? Very mature group, I can already tell walking in here.
Yeah, well, Peyton, on the other hand, he comes up from middle school, so
I love it.
he's a little tall.
He may skip other times.
For a sixth grader, he's a little tall for a sixth grader, but he's advanced now.
Well, I was just talking about you. This is the only human I've ever known to successfully change the room number in the This half the room used to be something different until maybe month.
That's right. Changed it.
And this paint, look at it.
Oh, no.
Isn't that
Okay,
great?
yeah, that's what.
Yeah, well, I'm not done yet. Well, it would have been Mr. Bennett yesterday, the twin, Mr. Bennett.
Yes.
Is going to help me paint a mural. Former student of mine,
Yeah.
Madison Clark. No, we're just gonna do we're doing about sand.
Mountains, I like it.
We're at Appalachian. We're gonna put some sand. I'll put some lines. Right now, I have a spear and roll tribe to go up on the wall.
You know what I think? Maybe those. This is just next time. If you could take a picture of whatever's outside.
Yeah,
That'd be pretty.
it would be cool.
I don't know how to do that. Yeah.
Yeah.
If we can paint a realistic
So
picture.
most definitely in the corner, you're gonna see Eastman. You can see the smoke coming out. The haze coming off.
I'm excited for things to be painted.
I was bringing it out.
Let's keep that around. I think it'll be good. Jackson.
And then Gracie. This is Gracie. Hey, Katie. Gracie? That's Gracie's.
I'm Emily, Wally, and Holly's brothers. Keep the faith.
All right, so we should be caught up here. Does anybody have any questions over their homework? How about the last one? Addison, do you have any questions? Which one? So to rehash.
Oh, you've already had that.
All right. So, guys, the idea here is to add the two equations together and get rid of one of the x's and the y. The only way this happens, and the very first one is already set up for you, it has the same coefficient. If the numbers in front of the x's or the y's are the same, you're kind of already set up for it. So this one's set up. So when I add these together, I'm going to get a 4x, and over here I'm going to get a 1. Okay, the y's get eliminated. It's gone. So then I would divide by 4, all right, and that would give me x is equal to 1/4. Okay? Now, what you're going to do here is there's two different things. You can substitute it back in and solve for your x, or you can do a double elimination. To do double elimination wouldn't be too terrible on this problem, and plugging it in is not too terrible. You can choose which way you want to do it. But this one was going to be, in this case, would have been x equals 1/4. Now, I'm going to redo this one, Addison, but you see this one's already positive and that one is positive on the x. So I'm going to leave the top one the way it is. Then on the bottom, I'm going to multiply the bottom one by a -1 to all of those. So that makes that a -2x. That will make that a -y, and that will make that a -4. Okay? So now when I add it together, the x's go away, leaving me a -2y and a -7. So when I divide by a -2, I'm going to get y is equal to 7/2. So then I write my ordered pair when I get done. I have to have an x and a y as my solution. So that's what it would be. Okay? So if I'm looking at number 2 there, Addison, what would I eliminate? The x's or the y's? the y's. But I can't eliminate them right now, okay? So Peyton, what did we have to do in order to make that happen? Yeah, we needed to multiply one of the equations, and it doesn't matter which one. You just got to pick one and make it opposite. So that's what we're going to do here. I'm going to multiply by a -1, and then I'm going to have that 3x plus 4y equals 18. And on the bottom, I'm going to get a positive 2x minus 4y equals -8. So when I put this together, as you can tell, the y's cancel. I'm going to get a 5x is equal to 10. I'm going to divide by 2, so x is equal to 2. Divide by 5, sorry. Then x is going to equal 2. Now what do you do, Peyton? This one I'm just going to substitute back in. It's a nice number. Over here I had a fraction, so it's kind of like hesitant, so that's why I did double elimination, because it's set up really easy. This one is set up really nice to go ahead and take the 2 and plug it back in to that right there. Now I'm going to write the equation out to be 3 times 2 plus 4y is equal to 18. Okay? Now, go ahead and make that a 6. Subtract the 6. All right? And so I'm going to get 4y is equal to 12. Divide by 4. So y is equal to 3. So you get 2, 3. Okay? So that is the process for elimination. Okay. Mr. Irvin, he's testing me to see if he'll come back later and see if the door's unlocked. When he unlocked it, I had mine locked. He didn't lock it back. So he's gonna come back through. All right. So what did I say about fractions yesterday? What to do if you got a fraction? Multiply by the denominator. Get rid of that fraction to start with and work with the clean slate. Okay? In this one here, you might, because, Addison, if I look at this one right here, you see that's a 6. If that was a -6, I'd be in good shape, correct? So that would be a -6y and 6y. So I say multiply by 2, but what if we multiply by -6 to each of these? Well, then that would give me -18 over 2, which would be -9x. Then I would get a -6y. Then I would get -54 divided by 2, which is -27. So I can just do that all at once. Then that will save me a little bit of headache. All right? Now, what they did over here on the board is what I asked yesterday. Multiply by 2. Go ahead and put it into a form that is a little bit easier to deal with. You can see what they did. And then they multiplied the top one by a -3. They ended up exactly where you are now. Okay? Whoever did number 3, they said, it's a good job. That's exactly the format I wanted. Okay? Here I did it in one step. All right? Now, you go ahead and put this together. I get -7x. The y's cancel out. I get -21. Divide by -7. X is equal to 3. Again, you have a choice here. You can do a double elimination, or you can just take the 3 and plug it back in. All right, so then you would have gotten y equals 0, so 3, 0 was the solution to this one. Okay, so the process is the same for the rest of them. I don't know if there's any that are like crazy. Maybe number 4 was probably the hardest one. Yeah, number 4 was the hardest one, yes. So I want to address this one real quick because we didn't have an example like this one. All right, so that's a 5, that's a 2, right? That's a 4, and that's a 3. It would have been positive plus 3y. Can I change one of them to make it match? Because I need it to be like negative 12y and positive 12y. I need it to be either like positive 10x and negative 10x. I need them to be the same number, right? They're not going to be the same unless I manipulate both of them, okay? And if you look at number 4 on the board over there, they have 12. They decided because one's positive, one's negative, they took the top one and multiplied it by 3. And then you should have taken the bottom one and multiplied it by 4. So that's where they're getting that 15x minus 12y equals negative 18. And on the bottom, they got 8x plus 12y is equal to 64. That is where they got those from because you have to multiply the top and the bottom ones in order to get that to work. Okay, that is the toughest one, and I would make sure I know how to do that problem. If you can do that one, then you'll be able to do the ones that are on the tests and quizzes. All right, quiz tomorrow, right? Yeah, quiz tomorrow. Quiz Friday. Tomorrow's Thursday, right? Quiz tomorrow and quiz Friday. Yeah, quizzes back to back, and you have a test on Tuesday. I should have given this quiz today. What? I told you, it's on Canvas. If you go to Canvas, it's been there for a whole week. Quiz 2 and 3 right there. It says it. In my quiz line, that's the grades. If you're ever wondering, right here in red are what's being graded for this week. Okay? What's down here as class recordings, those are the recordings I do. Those are your openers, and this is your homework. There you go. All right. Oh, here is your unit. If you want to know what's in the unit, these are your learning targets. I can identify a function graphically. I can use function notation to evaluate. I can use slope intercept form, point slope form, and standard form to graph a linear function. I can write an equation of a line. I can solve a linear equation. I can solve a system of equations by graphing by hand and with my calculator. Right? That's the one we just finished. That was yesterday's homework. I can identify how many solutions a linear system has. Does it have one solution, no solutions, or many solutions? I can solve a system by elimination. I can solve a system by substitution. Those are the learning targets. If you can't do one of those, then that's where you need to be in the tutoring and make sure you got figured out before the test on Tuesday, or actually before the quizzes on Thursday and Friday. Right? So your learning targets should be at the very top right here. Say unit 0, or it may say unit 1, and your learning targets are there. Okay? Plain and simple. They're written in kid standards. Those are kid-friendly standards. If you look at the state, you could not make that head to tail. It is really, really tough to read the standards that they write. It's like in Old English or something. I don't know. All right, so we're going to go to note set 5. On mine, it says 8. Because we didn't change it. So this is note set 5. The same one that I have up here on the board, which is note set 8. We did matrices and systems together a couple years ago when we added matrices into the curriculum. We changed up and said we want to utilize the systems away from matrices. So matrices are going to be coming up next. So, guys, I would say matrices probably is really easy. Hopefully you're going to make an A or B on this test coming up. You want to score as high as you can the first 9 weeks. As I said, the second 9 weeks we get into factoring and polynomials, and it gets really, really tough. And if we have winter weather in the way, we have Thanksgiving in the way, we have fall break in the way, they all are hesitations in your education, so the flow doesn't keep going, right? So you kind of get stalled out for a little while. it would be better if we did, and we just run through the whole 18 weeks to be done. Okay? It would be better for you. If you can pause and just continue to work out, right? Like if you're trying to build muscle and you go, all right, I take a week off here, or I may take 2 weeks off here, it necessarily doesn't help you gain the strength that you were looking for. Okay? So rest is really important if you're trying to build muscle. You had to have those built in properly. So breaks are warranted. Maybe at the end of the 9 weeks, that's when fall break should happen, and Thanksgiving. Okay? All wrapped into one. Let's do a week and a half or 2 weeks right there. Take a break. Then do another 9 weeks, and then we get Christmas holiday for like 2 weeks. You know what I'm saying? And then we go 9 weeks, and we take a spring break. And then we go 9 weeks, and we're done. And we don't have these 4 days in here. We don't have these, you know, every single time we turn around, we're out for this, we're out for that. You know what I'm saying? And it causes, again, conflict. So if we have snow, that really kind of makes a disruption in what we're trying to learn. It's like this hesitation. It's not always the best. All right, so previously in this case here, Addison, we graphed them, we did elimination, right? Yeah, I'm going to call your name to make sure you're focused and paying attention up here. All right, now, so in this case, now we're going to do what we call substitution, right? We have state all the ways you can solve. You know all the ways? What are all the ways? Substitution one, elimination is another. I'm lazy, so I'm not going to write that word. And then we got, what's the other one? Graphing. And there's another one that you could use, but it's not very good. Trial and error. You could just randomly plug numbers in and see if they work. How much fun would that be? So on a 10 by 10 grid, how many points are on a 10 by 10 grid? There's 100 in one quadrant. So there's almost like 400 points that you get to pick from. So you have a 1 in 400 shot of actually getting if it's not a fraction. All right, so in this one here, we're going to do substitution. Now, substitution, all you have to do is look for the coefficient. See, that's a 3. I mean, that's a 2. That's a 3. That's a 1. That's a 1. You want to look for one that has a 1 in it. The one that's in front of the x. So there's no number in front of it. You're doing good. So I'm going to take the very top equation. And then, since they're both 1s for the x and the y, just pick one. I don't care which one you want to solve for. I'm going to solve, in this case, I'm just going to go ahead and put it in slope-intercept form because most people kind of identify with that. So I'm going to get y equals negative x plus 4. Okay? So I'm going to take this top one. I'm going to choose which one I'm going to solve for, and then I'll solve. Now, the next thing you're going to do is you're going to take that, because that's what y is equal to, and you're going to plug it in right here. Which means another word for plug in would be substitution. So we're going to write this as 2x plus 3 parentheses negative x plus 4 close parentheses equals 9. Sloppy handwriting. That's okay, though. All right, now I'm going to do what next? Distribute. So 2x plus negative 3x plus 12 equals 9. The key with this is you don't have an x and a y. Now it's an equation of just x's in this case. So I'm going to go ahead and do the math here. I get negative x. When I put those together, I'm going to subtract the 12 over here. So I'm going to do all at once and divide by a negative 1. And so x is equal to positive 3. What do you think you're going to do with that 3? Yeah, this is substitution. So it's really double substitution. So I'm going to take that and plug it back in here. So I'm going to get y equals negative 3 plus 4. So y is equal to 1. So guess what my answer is? 3, 1. All right, so common mistake that is made in this one is taking this and plugging it back into the top one. If you do that, you'll get infinite solutions every single time. Because you're taking the line you're working with and you're plugging it back into itself, it's the same line. So you're going to get infinite solutions. So if you're doing your work and you get infinite solutions, you want to make sure that you use equation number 1 and you plug it into equation number 2. All right? Will infinite solutions show up? Yes. It is something that will happen. Okay? How do you know if you have infinite solutions? What will happen? Yeah, but what would happen when you're solving it? What would happen? How do you know you have infinite solutions? They equal each other. That's right. You would get down here and the x's disappear and you would get like 3 is equal to 3. If they're equal to each other and it's a true statement, then everything works, or all points on that line. If it was 0 equals 3 or 5 equals 3, then it's false and it won't work. Okay, which means it's a parallel system. Okay. Let's move on down here and take a look. It says, now you try. All right. Now, in this first one, Knox, I'm looking at the number 1 here. Which variable are you going to look at? Or you should be going eyeballing real quick. The x or the y? Yeah, the y, because it has a what in front of it? It has a -1 in front of it. So that's the one I'm looking for. You see that, Kate? Kate is great. All right, now, her sister has all the great stuff. So in this one here, guys, I want to solve for that y. So all I'm going to do here is going to move this 3x over to the other side. So I'm going to get -y equals -3x plus 1. I want to switch the signs, multiply by a negative, make it this. Now, Knox has already pointed out, we've already got it solved for y. All I have to do now is I'm not looking at the top equation anymore. I'm only going to work with the bottom one, and I'm going to plug the y into that. So when I rewrite this, it's going to be 3x plus 2. And then, remember, it's this statement. This is now your y. Your y is now going to equals 3x minus 1. So you put 3x minus 1 in. And then it is equal to 16. Now you have a little bit of algebra. We're back to solving an algebra equation, which you should know how to do. Okay? So we go through the math here, and I think I get 6x minus 2 equals 16. I think I'm going to get a total of 9 x's on this side. I'm going to add the 2 over to the 16, which will give me a total of 18. Divide by 9, so x is equal to 2. Take the 2 and plug it back in. Now, you know what? You can plug it into that equation, you can plug it into that equation, or you could even plug it into the new one that you created. Okay? That is already a y equals. So if I put a 2 right there, it is 3 times 2 is 6 minus 1. That is 5. So y is equal to 5. So I need to write my order pair. 2, 5, somewhere on my paper, box my answer so it's a standout so I can see it. Okay? You've got question number 2, number 3, number 4, number 5. You got 4 more to work on. So go to town while I erase the board over here, and I'll come around and help you out if you got questions. I will come around and help you out. And then I will do this real quickly on the board at the end, just to double check your work. If you have a neighbor you can bounce ideas off of until I can get to you. Okay. Good job. So this. Because it's in the next into the lines are off. They usually like that. Okay. Now how do you that little shortcut right there? Just X, Y, such that that means this such that so this is like I'm not English guy, so I'm going slash. You've already got that right. So I see what you did. Why is that one's obsessions. You don't say that. You just take, you got to write it in one paragraph, correct? So you got to write that. So you don't want. You say in X, Y. Yeah, pick one. You made a typo in that one. You have to fix it. Oh,
Zero is divided by 0.0. 0 times 1 is 0, but 0 times 0 is
0 divided by 0 is black hole.
So does that mean the solution or
The same one. Anybody else have a question? That's good. Not too terrible hard. So this one, really in this case here, I'm doing the second one. Guys, it is already set up as x equals. So Addison, I didn't really have to do any work here. You could have left it like this and just take that and plug it in for that one. So 3, I knew y plus 1 minus y equals 3. Distribute 3y plus 3 minus y equals 3. I'm going to subtract the 3 from both sides. I get 0. I'm going to get 3y. That's going to give me 2y. Now 2 into nothing is not 2. When you take something, you try to divide nothing by something, it's still nothing. Now, you're not allowed to divide nothing by nothing. Okay? And you can't divide by nothing. It doesn't make sense. Okay? It's kind of like, okay, so if no pizzas arrived in this room, right, and we divide all those pizzas by the number of students I have in here, which is 25, let's say 25 students, I still have nothing. if we're not in the room and 25 pizzas show up, it doesn't make sense. How are you going to divide 25 by nothing here? Okay? So someone's been praying. Right? Just don't make it you. All right? So this is y equals 0. So take the 0, plug it back in right there. So x is equal to 1. So 1, 0 should have been that one. Now, as you're doing this one, most of you guys just move the 3y over. You got 3y plus 2. You plugged it in. You had 4 times 3y plus 2 minus 12y equals 8. You did your math here and got 12y plus 8 minus 12y equals 8. Now, the y's are gone. There's 0 of them. There's none. They're gone. So all you got is 8 is equal to 8. If 8 equals 8, then everything works. All of them work that are on that. And so we have that special statement. Remember, you have to write it as an ordered pair. And the ordered pair is an x and a y. But you can just say any x and y on the line and then write one of the two equations. Like you could put 4x minus 12y equals 8. They're the same line. So you can even say same line on your test. So you guys can remember that it's the same line. And then that's what I'm looking for. Okay? And for some source statement, you know what's going on. All right, now the next one here. This one comes up like 0 and 1/2 or something like that, or 1/2 and negative 1/2, right? This is no solution. Mr. Freeman says no solution. All right, so this is no solution. Does anybody need confirmation on that? Need help? Can we do this problem for you? All I have to do is have one person say, yeah, I need to see it. Yeah? All right. So to see this one right here, what I'm going to do is that has it already as an x, correct? It's set up just a single x. I want to solve for x in the top equation. I can solve for y in the bottom equation. It makes no difference which one you pick. So I'm going to move the 2y over. I'm going to get negative x equals minus 2y plus 4. I'm going to go ahead and multiply by a negative, and that would change all my signs. Or you can say I'm dividing by negative 1 on all of those. That's how your signs got changed. I'm going to take this and plug it into that equation right there. 1/2 times 2x minus 4 minus y is equal to 2. Now I start to do the work here, distribute here and here. I'm going to get x minus 2, not x. That's supposed to be a y. That's a y. So y minus 2 minus y equals 2. So I got negative 2 is equal to 2. That is not true. That is a false statement. If it is false, then you have no solution. You can't say all solutions on the other one. It has to stay, it would have to say any solution x and y. So you got to give me the x and y. All right, questions? Number 5. Which one did you solve for? Lily, what did you solve for in that number 5? You did y first? Like, what'd you do in this one? All right, so she solved for x, so she can actually solve for y. That's what she's saying. That's what she. Then you're going to take this right here and plug it into that x. So she rewrote this as 2 times minus 4y plus 12 minus 8y equals 4. Then distribute this one here and here. So negative 8y plus 24. subtract the 4, 24, right? So you got negative 20. You put your y's together here and here. That's supposed to be a minus sign. There's no equal sign there, sorry. So that would give you negative 16. That's what you got. You divide by negative 16. So y would equal, divide by 4, 5 over 4. Whoop, whoop. You like that, Peyton? What are you going to do with that one? Yeah, you want to plug it back in. So we're going to plug that one back in to that equation right there. Makes no difference which one. What's nice about this one, Peyton, is that that's a 4 out front. So when I multiply by 5 over 4, what happens to my 4s? Yeah, they just do this nice cancellation. So x plus 5 is equal to 12. Subtract the 5, so x is equal to 7. So 7 comma 5 over 4 is the correct answer. Okay? Questions? You want to have, we did this in A block. I went to 5 over 4, and then I said, you know what? I don't want to plug that back in. So I had already found the y. So I just multiplied the top one, okay, by a 2. And then I did elimination. Okay? So I'm okay with you when we're saying solve by substitution. You did substitution, that's fine. If you want to do double substitution, that's fine. If you want to do substitution and then elimination, that's fine. Okay? But I need the first one to be done by substitution. There will be, again, on the test, there will be a section you have to graph, one you have to eliminate, one you have to substitute. Then we'll have a section where it says, hey, you choose your method. Okay? And so we'll do those 5 problems tomorrow, and then you can kind of get familiar with that. So I'm going to stop here. You've got 11 minutes. I've got a vaccine for pneumonia. Bacteria yesterday. My arm's sore. Protect myself. All right, now, I work with students, so I need to be vaccinated like heavily. So, Canvas. Math Excel. Some of you guys, I put in your Math Excel grades, and some of you guys had not even logged into your Math Excel. So in Aspen, I put in there, has not logged in. You turn in your homework late. I'm going to put a late on there. Actually, you should have that homework turned in on Monday. Okay? Now, if you were not here on Monday, then I expect you to have it the next day. Right? When you come back, I'm hoping you have it. If you were out several days, I do have a little bit of a grace period there. I'll give you another. Okay? You can talk to me about it on the homework piece of the problem sets that are due on Monday, but they're due on Monday. All right? If you happen to drop them off during lunch or something like that, I'm okay with that. But I'm kind of hesitant because I think you're probably just copying them from your friends. Okay? It's not supposed to be a copy. All right? So I don't need Colton's work done on all your papers. Okay? Colton, just don't hand it out to them. Let them do their own work. Okay? I don't, like I said, I mean, I can copy over and over again. If you need help, I'm here every morning at 7 a.m. and you come in and do some homework every single day. I'm giving you time there. If you think you got dead space in class and just sitting there, you can do your homework. Okay? I try to do their homework when we do have homework problems. I'm trying to give you at least some points there. All right. Easy Bridge is going away. So if you're doing this, this is the first week 1 and week 2. You'll do your homework for Math Excel here. This Pearson button is going to show up, and this is the one we're going to be using. So on Monday, we're going to make sure everybody logs in through Pearson, this button. This, and then we'll pull this up, and I should say, I'll show you how to remove that icon. We're going to get rid of that one Okay, so the easy bridge will be gone, so it won't be in the way. But if you have this and you know how to log in, you can try it. But I haven't learned on the student side. I did mine's already. So everything's going to be there. The only thing you'll see on Monday is Math Excel 3 and the 3 emergency subs. Okay, those subplans, remember, don't do those. Those are there for if I die. Okay, so that's what they're for. So I don't plan on you ever using them. Okay, but I had to make the plan just in case. I'm here, Carter. All right, so you have the rest of the time to go ahead and do some homework or whatever you need to do. Okay. Is there a flood? Yeah. No, it did not rain. Oh, it says it something like there? Yeah. Flood statement, flood alert. Nah, it's just a flood watch in effect. Well, I did not see any of it. I had my eyes closed when I walked up this morning. Yeah, I had my head down. Let's just put it that way. Because if I look up, I'm gonna get like rainwater in my eyes, and I don't want that. That's that Eastman Domtar particles. I mean, you sting your eyes. Get some sort of acid rain here. So, well, I parked my car in the garage. You could, right? Why would you choose? No, like it's all. Next month, what I do next no, I just can't. Yeah, because you could do 8 as well. That one does. Well, that's why that one. I'm on the small. What's the most? 4. So like 5 something. So that's not 20. Yes. Isn't that? Probably do if I cover this, I get 0. It's what you said, right? No, it doesn't. The other one would be over at the line. The other one is 1, 1. 1, 1. So we have 0, 1, 2. That would be the intersection. So we want to grab this one. Now that should match. Okay, so you're having to do by points. Now there is in that program there is edit by points. So when you're doing that box at the top, and you click on the point, you're going to change it. So it's like.
I don't even know what this one says. But mine's like backwards. Like the handle is so.
So,
What do you have in this? Katie, what do you have? What do you have?
I'm putting it in on
Oh, no, I don't want to bring home those. That's fine. So you're almost just saying. I'm not going to go back. That's a lot. It's mainly that was my main focus. I wasn't put that on.
Oh my god.
Right? I do lots.
Have a good day.
Now you can do
When you multiply here by 4, you forgot to multiply, that's 24.
Oh, okay. Thanks. Yep. Yeah, that's going to be, we have to solve systems by calculator. Yeah. Use the matrix. What it is, I put my 2 by 3 in. I put the coefficients. You solve it, right? Yeah. Yeah. Then it's just a matter of remember what buttons go. Yeah, trying to get it there. Yeah. This only I switched because she was up there and down here. It's better down here. I'm isolated down here, so I'm not with the other teachers. I've been doing like on cheese and go over something.
Yeah, so what you guys do, like, what happened? I was over here. Since the other class was mine, I don't know.
Painted the wall. Yeah, so I got it all my characters. So eventually I'm going to paint that on the wall. Do you have calculus?
I'm not. I'm just the calculus before school. That's what I'm supposed to be like. I have ADHD, but yeah, it's like super.
You're really you think
I'm not even taking it.
it's so much you got to agree.
No, I'd be an aviation degree, engineering. I need to back on it.
Minor or major. You get enough to you know you only have 3 credits you need. Or I mean, you get a degree to do it. Okay, once it's here to say, it's a fallback. Just figure something out. Math is
I spend a lot of days in practice.
It's not lazy, it's just hard enough.
I just needed to make sure I was doing it right.
I'm so